Graph theory, pages 12 and 13. While Euler's theorem gives us a way to know if a graph has an Euler path or circuit, there's not a way to tell in general if a graph has a Hamilton path and or circuit. That said, there's one condition that does indeed guarantee the existence of a Hamilton circuit. When is a graph guaranteed to have a Hamilton circuit? Every complete graph with more than two vertices has a Hamilton circuit. And in fact, the number of Hamilton circuits in a complete graph with n vertices can be found by the formula quantity n minus 1 factorial. So what is a complete graph? A complete graph is a graph that has an edge connecting every pair of vertices. So draw a complete graph using the vertices given. And they ask how many Hamilton circuits does a graph have? The easiest thing to do would be to figure out how many Hamilton circuits it has first. So there are 6 vertices, so 6 minus 1 factorial gives us 5 factorial, which is 120. Okay, so that's how many circuits, Hamilton circuits there are. That's not how many edges there are, luckily, or else this would take a while. So I'm going to go ahead and start drawing from this particular vertex, an edge to every vertex. Okay, then I'll start with this one. And then this one. And then this one. Let's see. And I could end up with this one. I'm just going to make sure. So every vertex should have 5 edges coming from it. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Very good. So with Hamilton circuits, our focus won't be on the mere existence of a Hamilton circuit, but on the question of optimization. That will be the most important thing that we're looking at and the best application possible. Can we find the most efficient solution to a given problem? This type of problem is often called the traveling salesperson problem. The most efficient may refer to the distance traveled, the amount of time spent, or the cost of travel, to name a few. Let's suppose a Seattle-based salesperson needs to give sales pitches in 4 cities. They look up airfares between each city and puts the cost on the graph. This type of graph is called a weighted graph. In a weighted graph, numbers are assigned to the edges. Note the weight given to edge has nothing to do with the length of the edge as drawn on the paper. So they're asking, is this a complete graph? Remember, a complete graph is a graph that has an edge connecting every pair of vertices. Okay, so if we have 5 vertexes there, every single vertex should have 4 edges leaving from it, and I'm inspecting that. It looks like it does. So yes. If so, how many Hamilton circuits does it have? Well, if I have 5 vertices, then 5 minus 1 factorial gives me 4 factorial, which is 24. Okay, so how do we find the optimum solution for the problem? In other words, what is a circuit with the lowest cost? This is a question without an easy answer. Only one of the methods below guarantees that you find the optimum solution, but it can require an immense amount of work for graphs with large number of vertices. I'm going to have to make a comment here that with the fact that we have computers now would make this much easier. So, but we are going to find 3 different methods here for finding an optimum solution.